Hello, so it's day 31. I guess it's 9:45 in the morning. I would like to wrap it up fast because I have a exam tomorrow and I have a lot of exams after that too. So let's just get to the coding part, I guess. Uh, so I have seen a question in yesterday's contest, I guess. So let's try doing that. Oh, yeah, I haven't written the yesterday's contest. I would actually, I would do it if I'm not exactly having a exam tomorrow, but I have an exam tomorrow, so let us see this. Yeah, first let me submit the first three questions. I opened it in the last 30 minutes and I just quickly ran through the first two questions and solved it from another account. But it didn't take my submissions because I didn't register for it. It just took me 15. Yeah, first two questions are very easy. So I did them. Let us try submitting them. I don't know if it works or not. These are very easy questions. First one took me. First one took me like uh, 10 minutes. No, like 7 minutes. And second one took me another 8 minutes. So oh shit, damn. Let me just quickly solve this shit and move to the next question, I guess. Oh, I misread the question, so that's why it took me less time. Okay, fine. Wait a second. No, I didn't misread the question, but let's see. You're given a permutation, you are supposed to make it, what is it? You can swap which differ by one. You have to make it in such a way that pi equals to I. So you basically have to make it 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. Let us say one. So my claim is you can't move one more than two places from where it is. Like you have to exchange one with only two, right? Oh wait, there is another thing. Yeah, sure. You can swap. So you can only swap one if the adjacent element is two, right? So if let us say one is at some position, so if you have to move it uh, to left, let us say. So two should be just adjacent to the one on left. So you swap those two. and now one place to the left and two goes behind one. So now you can't swap one from there at all. Yep. You can't move to, you can't get two, right? So yeah. So if you want to move one should be on either on the first place or on the second place. And if one is on the second place, then okay, that's the mistake. Yeah, I understood the mistake actually. Nice. What? What? Oh, shit. Mm, what now? Huh? Damn, dude. Let's try submitting this, right? I hope this works, man, seriously. Nice. Now let's get to the third question. So yeah. When we close two things, square number and Hong Kong side. What the F man, why the hell are you doing this shit? I don't like this at all. Like, why the hell do I give this much of a story and shit? Hey, seriously, why? Whatever, let's get to the question. For his birthday, Kohane wants to contribute them with a gift, and there are 10 power 6 available fillings of BBQ buns, numbered from 1 to 10 power 6 to ensure that no filling is exactly used once. And for any two ones I and j that have the same filling, the distance between them, which is I minus c, j must be a perfect square. Okay, I guess I yeah. So okay, there are, let us say, a1, a2, a3 and so on, an. All of them have same kind of ones. Okay, same filling. So it's, my claim is that this could be, if this is odd, it could be written as some 3 plus something, right? If it's even, it can be grouped into two. If it's odd, first you group the first three, and then remaining you can group them, right? So my claim is that any way there exists a there exists a way where a filling is used only twice or thrice, no more, no less. Okay, like, so there is a way where you can just take a filling, use two times somewhere you want, or use it three times somewhere you want, and that's it. So a filling can't appear more than twice or more than three times, and it also can't appear less than two times because it's given in the question. So can the perfect square be one? Like I minus a is one, right? So yeah, you can use one, I guess. No? Yeah. So I think you can use one, two. So let us say it's even, dude. Hey, come on then. Um, yeah. So if n is even, then I can just do just 1, 1, 2, 2, 3, 3, 4, 4, and so on. Because difference is 1. and it's even, it's a perfect square. Difference is 2, it's a perfect square. 3, it's a perfect square, right? So the only problem is with all numbers. So if n is odd, I should at least have a, so it is written as a group of 3 into p plus a group of q into 2, right? So there should at least exist one p, because if there it's 0, then it would become even, so p should be odd, right? What is the smallest group of 3 with squares in it? It's pretty simple. It's, I guess it is 3, 4, 5, if I am not wrong. Oh, it's this. So it's at distance 9. This is at distance 16. This is at distance 25. This is the smallest, I guess. Now, after removing these 3, the number of remaining, elements become even. So you can say one thing: if n is odd and less than 25, then there is no way you can fill it, so not possible, right? So my n is odd and greater than 25. Let us say for n equals to 25, can I do anything? So there are 8 here, and there are 15 in the middle. That makes it 22 plus 3, 25. So can I fill it somehow? The problem here is I can't do it because the elements here are 23, so 25 is also not possible to do. If I, let's say I have element here 26, let us say, so I was thinking you can't take this anyway, so maybe something like distance 4 from here, so that makes it 3 from here, right? Or yeah, so That leaves a 2 here, and I would fill here. And how many are remaining here? I've used 3, so there are 12 here, there are 8 here, and you can just fill those. So if n is odd and less than or equal to 25, it's not possible. And for n greater than 25, it's good. If n is even, just do 1, 1, 2, 2, 3, 3, and so on. If n is odd, then put 1 at 1, 10, 26, and 2 at 2 at 23 and 27, and then you can just pay 2 each. Okay. Does this work? So yeah, I think it should. If you're wondering about the time here, it's just I often tested it during the contest in last 30 minutes to solve it, but I didn't because for obvious reasons, I guess. Is there a T? Oh, there is a T. T is not one, no? No, it's not one. And sum of n should be less. Okay, nice. So you run this. If n percent to n less than 26, see out -1 and L and continue. If not, if n percent to then v of 0 equal to v of v of 9 equals to 1, v of 25 equals to 1, and int fill equals to 1 initially. V of 22 equals to 1, so 2, and V of 26 equals to 2, and my fill becomes 3. Now int I equals to 0, I less than n, I plus plus, if b of 0, sorry, b of I, then just continue. If it's not, then do this, b of I equals to fill. And then just print it. Oh, damn. Yeah, I think it's fine. We can just submit this. Let us see if it works or not. If it does, that's it for today, guys. I won't be doing anything else. Yeah, it does. Okay. So yeah, that's it for today, and we'll meet again tomorrow, I guess. Bye then, because I have to prepare for an exam. Not exam. It's on numerical computation. It's like the course is like based on how you solve math using computer. So like interpolations and stuff, solving matrices using computers, uh, and answers is it's not assuming. What do you call it? Like I don't get the word now. Like it's something like find the root. No, what do you call it, man? It's a very I'm whatever. Yeah, it's like you have to get a value close to the root. I don't remember the word exactly. Like it's whatever. Yeah, so it's something like that. Like given a linear equation to solve, how do you solve it faster? Or maybe how do you get to the closest answer? Might not be the exact answer, but close to the answer. So yeah, yeah, approximation. Fuck that word. Yeah, how can you approximate a function? How can you approximate whatever you're given, like data fitting and stuff? So given a data, how do you fit the closest line possible, like best line possible? You see, if there is a lot of data, you can't fit a line, function passing through all the data because there might not be a function that's like that because uh, it's like overfitting. You know what I'm saying? uh, if you have a function passing through all those points, it's just not worthy. Like it will do very good for the given data, but it will definitely fail for other points. So yeah, so we don't overfit stuff. We fit a line as close as possible, which satisfies the given condition. So let us say we are given data x, and yeah, let us say we are given we have to assume a polynomial. Let me just show you why the hell am I talking this stuff. I'll just show an example of that. What I'm doing exactly. It's not a big thing, but yeah, it's this part. So let us say you're given a lot of data and you want to fit a line. You just so you take the data in a matrix and you take the quotients in another matrix X. Yeah, like this. So you take the points T1, sorry. You take the points T1, T2 in a matrix. This is given. And you take the quotients X and X2. You have to find this. So X equals to, there is another matrix. So Y, X equals to Y, the solution won't exist because it's not the matrix is not exactly square matrix, right? So Ax equals to Y doesn't make any sense. So you try to find X that minimizes the norm of Ax minus B. So it's as close as to the solution possible. I mean, the closest you can get actually. So what is the least value of Ax, norm of Ax minus B, and you try to find that X. So it's not the method that's actually weak, it's actually the data itself. So you can't exactly get there doesn't exist any x such that ax minus b equals to 0. So norm of ax minus b is 0. If there is, we can find using the method, but there mostly won't be any ax minus b equals to 0. So you take the next text, that is minimum of ax minus b. Yeah, whatever, you get it right. So that's the exam tomorrow. I have to study for that, and yeah, and that's it. Bye.